Hi class, this is video 22 in which we are going to discuss the bones and the joints of the leg and the arches of the foot. Okay, bones and joints of the leg and their movements and the arches of the foot. So let's get started. Now a lot of these bones I'm sure we already know, so this should be pretty quick and pretty straightforward. So we're going to start out with the tibia. So the tibia is this bone. Oh, before we do that, let me say that this model that I have here with me today is a left foot, okay? And remember, a lot of times when you're looking at diagrams in your book, you're looking at a right foot or a right whatever. So bear in mind that this is a left one, so things might seem like a mirror image perhaps to what you're looking at in the book. Okay, so we're starting with the large bone here. This is the tibia. So the tibia, the proximal end of the tibia has a few articulations. So we have first this one right here that we've already talked about, because this is where the quadriceps attach. This is the tibial tuberosity. Okay, that's the tibial tuberosity of the tibia. So that's where the patellar ligament comes down and it attaches there to the tibia. That's that's easy to palpate on your own or on somebody's tibia. So that's the tibial tuberosity. Above that, this whole flat top part of the tibia is referred to as the tibial plateau. And in that tibial plateau, there are these points that stick up that are the eminences. Let me look at this, exactly what they're called. Intercondylar eminences. So because they're between the condyles. So the tibial plateau is this whole big flat part on top, but we have here a lateral and a medial condyle, just like we do in the femur and in the humerus, even though we don't call them condyles specifically in the humerus, but same idea. So we have a lateral condyle and a medial condyle. So between these two condyles, so this is inside the knee joint on the top of the tibia, we have these intercondylar eminences. So those are going to be places for ligaments to attach. Okay, so we have the medial condyle, we have the lateral condyle. So for reference, on the tibia, the lateral aspect of the tibia is where the fibula is. So if you see the fibula, then that's the lateral aspect of the tibia, that's the lateral condyle. So the tibia is a long bone, so of course we have shaft. From here to here is the shaft of the tibia. The tibia is kind of a triangularly shaped bone, if you can see that. And so right in the front of it, there's kind of a corner, and that's called the anterior border. And the anterior border, I'm sure you know it well. It's the part of the tibia that you walk into coffee tables with when you're walking around in the dark, or you bump it on the bed or whatever, and it feels terrible. That's that very front kind of sharp edge of the tibia there. That's the anterior border. So the anterior border then separates these two surfaces. So we have the medial surface, so it's fairly flat surface here, the medial surface and the lateral surface. And then if we turn it around, there's a posterior surface. So it is very relatively three-sided, not so round the way some of long bones are. At the distal end of the tibia, basically what we have here is the medial malleolus. Okay, so down here, we're about to talk about the fibula, but we have two malleoli down here, and the tibia has the medial malleolus. Okay, and the fibular notch is the other thing on the tibia. So the fibular notch is right in there. With the fibula in place, you can't really see it, but it's right in there where the fibula and the tibia come together. All right, let's look at the fibula. So the fibula is super simple. It just has a couple of landmarks. So at the proximal end of the fibula, we have the head. Okay, so up here, and which is like kind of supporting that the lateral tibial condyle. That's the head of the fibula. We have the shaft of the fibula, and then down here we have the lateral malleolus. Okay, so on the tibia it's the medial malleolus, on the fibula it's the lateral malleolus. Okay, moving on down, naming the bones here, and then we'll go back and talk about the joints. So the next set of bones here are the tarsals. So the tarsals are very much like the carpals of the hand, but they're a bit easier in that there are only 7 of them. and 3 of them all have the same name. So it makes it a lot easier to learn their names. So the first one here is the talus. So the talus is the one with the slit in it because it's making the joint here, but it doesn't really have a slit in it. But this one right here is the talus. Okay, so it comes around all through there. That's the talus. And if we look at the side, we can see the talus. This is the medial view. Here's, oh, sorry, that was the lateral view. This is the medial view. It's a little harder to see, but there you can see the line between the talus and the next joint, or the next bone, which is the calcaneus. The calcaneus is the heel. It's the most posterior of the bones of the foot, and and it's by far the largest of the tarsals. So this is the calcaneus. So again, this is a medial view of the calcaneus. This is a lateral view of the calcaneus. Posterior view. Okay, that's the calcaneus. Now, anterior to those 2 bones, so again, here's the talus. Anterior to the talus is the navicular. The navicular is this one here. The navicular with the arches should be up off the ground. It shouldn't necessarily touch the ground if the arches are intact. So that's the navicular. And then anterior to the navicular are the 3 cuneiforms. So this one's a little rotated here. So we have the medial cuneiform, the intermediate cuneiform, and the lateral cuneiform. Or they're also sometimes called cuneiform 1, 2, and 3. So the 3 cuneiforms are anterior to the navicular, and the navicular is anterior to the talus. On the lateral aspect, we have over here the calcaneus. Anterior to the calcaneus is the cuboid, and then directly anterior to the cuboid are metatarsals 4 and 5. So on the lateral aspect, we just go calcaneus, then cuboid, and then we're into metatarsals. Whereas on the medial side, we have talus, we have navicular, and then we have the cuneiforms, and then metatarsals 1, 2, and 3. Okay, the rest is exactly like the hand. So we have these long bones that make up the foot. Those are the metatarsals. So metatarsal means beyond the tarsals, and that's where we find those long bones. Each of the metatarsals has a base at this end where they articulate with the tarsals, and then a head at this end where they articulate with the phalanges. The one landmark to know additionally for the metatarsals is metatarsal 5 also has a tubercle, which is easy to palpate. And you notice it when you're learning the UB points along the lateral aspect of the foot, because you can palpate that and you know which points are anterior and which points are posterior to that tubercle of metatarsal 5. What else? So next we have the phalanges, and so just like in the hand, we have proximal phalanges that are just distal to the metatarsals, and then in the big toe, like in the thumb, there are only 2 phalanges, so we have a proximal and a distal, and all the rest of the toes, except this poor model is missing some phalanges here, but on the rest of them we can see a proximal, can we see it, a middle and a distal phalange that makes up each of the toes. Okay, let's go back and look at joints. So starting with the knee. So I don't have a femur here, but let's pretend this is the femur. So the femur and the and the tibia come together to form the knee joint. And so the knee, let's talk about actions of the knee. So actions of the knee include flexion, and flexion is, it doesn't happen quite like this. It doesn't kind of hinge open like that. Instead, it happens more like this, where there's like a slide between the 2 bones, and so then when the knee is flexed, it looks like this. Then it slides back. So anyway, flexion and extension are the main actions of the knee. But when the knee is in a flexed position, then medial and lateral rotation can also happen. Okay, so but only in a flexed position, medial rotation, lateral rotation. So those are the actions of the knee. The next joints are the proximal and the distal tibiofibular joints. So the tibiofibular joints they're really held in place very strongly with ligaments, and they don't move much. They move some, every joint moves some, but they don't move enough for us to need to name their movements. Suffice it to say that basically the job of the fibula is to support the tibia. It's this lateral support here for the tibia. Also, the fibula helps to create this more solid structure down here to form the ankle. So let's talk about the ankle next. So I just sort of glanced over those two joints quickly, but they're the proximal tibiofibular joint and the distal tibiofibular joint. The problems can arise with them because the fibula can move out of place a little bit, and then that would result in knee pain, or this would result in ankle pain. But that's something that a chiropractor or an osteopath can put back into place. Okay, onto the ankle. So the ankle is also called the talocrural joint. So talo refers to the talus, this tarsal bone here, that highest up tarsal bone. That's the talus, so that's the talo part of the talocrural joint. The crural part, remember crural refers to the lower leg, so the tibia and the fibula together make up the crural aspect of the body. So the talocrural joint is the ankle. So see how the tibia and fibula form this strong structure down here like this. And so on one side we have on the tibia side, we have the medial malleolus. On the fibula side, we have the lateral malleolus, and that's going to help to stabilize that joint medially and laterally. But we do have some movement, some medial and lateral movement in it. So movements at the talocrural joint include plantar flexion, which is this, dorsiflexion, which is this. So dorsiflexion is when the foot comes up toward the rest of the leg, and plantar flexion is when we point the toes. And then also we get inversion, which I can't really make this model do. Inversion is essentially like this. Eversion is like this. Okay, inversion, the sole of the foot points inward. Eversion, the sole of the foot points out. That's not a big movement because we want the ankle to be pretty stable, but that does happen some. Okay, next joints. So there are a number of intertarsal joints, and we don't need to name each of those specific joints beyond calling them intertarsal joints. And those are the shape of them. Those joints are called gliding joints, and so not a lot of movement happens at gliding joints, but some. And so it's kind of like in the spine where there are a lot of joints together. At none of those joints in particular is there a lot of movement, but when we get all of those small movements together, we get a bigger movement. And that's what we have here in the foot. So when we combine the movements of the intertarsal joints, also along with movements here between the tarsals and the metatarsals, so that would be the tarso-metatarsal joints, then we get what we call pronation and supination of the foot. So pronation is the foot pointing in, supination is the foot pointing out. So pronation and supination. And again, that's a relatively small movement of the foot. And, but it happens, pronation, supination. Okay, so there's that. So it's not all like the hand, right, where you can supinate it enough to carry something around and pronate it enough to pour that thing out. It's a very small movement in the foot. Why? Well, of course, because the foot needs to be super, super stable, because we're not carrying things around in our feet. We're supporting the whole body while we're moving around with the feet. And we're going to talk about that more when we talk about the arches. So moving on through the rest of the joints, we have metatarsophalangeal joints here. So the metatarsophalangeal joints are the joints between the head of each metatarsal and the base of the proximal phalanx. So that's the metatarsophalangeal joint, or MP joint. Those joints, the actions there are flexion, extension, and for these, hyperextension is a normal part of the range of motion. So flexion and extension, and this flexion is called flexion and extension. It's only at the ankle that we call it dorsiflexion and plantar flexion. So flexion, extension, and then also at the toes, if we splay the toes out, that's going to be abduction, and if we bring them together, that's adduction. So that also happens at the metatarsophalangeal joints. And then our last joints are the interphalangeal joints. So we have a proximal and a distal interphalangeal joint on digits 2 through 5, and just an interphalangeal joint at digit 1. And those are straight up hinge joints, so the only actions they do are flexion and extension. Okay, so those are the bones and the joints. And for the most part, the landmarks of the leg. And our last thing to talk about here is the arches of the foot. So there are 3 arches of the foot, and this model shows them relatively well. It's a little bit of a loose model, but we can see them pretty well. So there are 2 longitudinal arches that run this way. So the first is called the medial longitudinal arch. So the bones included in the medial longitudinal arch are the medial aspect of the calcaneus, the talus, the navicular, and the 3 cuneiforms, and then the 3 metatarsals, the metatarsals 1, 2, and 3. So that's the medial longitudinal arch. So that's an arch that runs this way. There is also a lateral longitudinal arch that is not as high as the medial longitudinal arch, and that runs through the lateral aspect of the calcaneus, the cuboid, and metatarsals 4 and 5. So there's the lateral longitudinal arch. So ideally, the medial longitudinal arch does not touch the ground. The lateral longitudinal arch is going to touch the ground. So think of walking. Ooh, here's some homework for you. Go to a sandy, lovely beach and take a walk on the beach and look at your footsteps, your footprints that you leave, and see what your footprints look like. So I want you to do that homework and then report back how the beach was. Okay, and so because what you'll see in the footprint is where your foot touches, which is not everywhere unless you have fallen arches. So if you have nice intact arches, you're gonna see the ball of the foot touching the ground. We're going to see the lateral aspect. Some people, we don't see that lateral aspect. Some people, that's nice and high too, and we just see the ball of the foot and the heel. But typically, we're going to see the ball of the foot, which are the heads of the metatarsals. We're going to see along the lateral aspect of the foot, and then we'll see the calcaneus. And we shouldn't necessarily, unless the sand is really deep or whatever, then we shouldn't necessarily see the medial aspect. All right, the third arch that we have is the transverse arch, and that runs through the tarsals this way, like essentially through the navicular, the cuboid, and the 3 cuneiforms, but this direction. So that creates, so where those arches intersect is the highest point of the foot. So we have the transverse arch this way, and then the 2 longitudinal arches that way. So where the transverse arch is, that's where we have the highest point of the foot. So the last question here then is, why do we have arches? What's the point of them? Well, there are a few points of arches, why we have them. One is that arches are stronger. So an arch is the strongest structure in nature. It's stronger than a column, and it's stronger than, like if the foot was flat, it may not be as strong as it being in an arch shape the way that it is. So the arch is the strongest structure in nature, and we need the foot to be strong because it's supporting the weight of the entire body. So we make this nice strong structure there with the foot, which is an arch. So an arch is a strong structure. That's one reason why we have arches in the foot. Another reason is that the arches act as springs, and both as shock absorbers. And in a sense, that's kind of the same thing. But each time we touch the foot down, the arches are going to kind of flatten out a little bit, and that absorbs shock each time we step down. But then it's like this spring-loaded thing, and it's going to help to spring us back up again. So they're shock absorbers and they're springs, and that helps us out when we're walking and when we're running, to help to kind of propel us forward and to keep us moving and keep us light on our feet. So one of the most important functions here of the arches is the shock absorption function. And one of the things that we see is if somebody has fallen arches, what that means is their foot is flat. So it would look kind of more like this, and on their footprint you would see the entire bottom of the foot instead of just that typical footprint shape. So with fallen arches, those people with fallen arches are missing that spring action of the foot, and they're missing that shock absorption action of the foot. So some of the things that we can see down the line in somebody who has fallen arches is with that shock absorption function missing, the shock of each impact of every step while we're walking or running or jumping or whatever is going to impact every joint up line from the feet. So the feet should be absorbing a lot of that shock. If they're not, then we might expect to see knee problems. We might expect to see hip problems in somebody who doesn't have healthy arches. Healthy arches are an expression of spleen chi. Spleen chi spleen chi lifts especially up through the middle of the medial aspect of the leg, and so with if spleen chi is sinking or if it's deficient, that's when we can see some collapse happening in the arch. But with healthy spleen chi, we should see a lift here, and the arches should be intact. Okay, so that is it for video 22, bones and joints and their movements and arches of the lower leg. All right, next up in video 23 is going to be, we're going to look at the superficial muscles of this part of the body, and then our next video we're looking at the deep muscles of this part of the body. So I will see you then.